Good morning, everybody, or whenever you're seeing this. Let's go over the homework to our first set of hypothesis tests. This was from Wednesday's lecture. So before we do, let's decide if we're going to check this homework right now. All right. So I'm going to flip this coin. Here it is. I'm going to flip it right here. And I've got my associate right next to me, Griffin. Griffin, should it be heads we check or tails we check?
Tails.
Tails we check?
Yeah.
Wait, heads we check or tails we check?
Tails.
Tails we check?
Yeah.
Okay. All right, I want you to see it. I want you to look at the same time. Ready? What is it?
Head.
No, that's tails. You see the eagle right there? That's tails. So we are checking this homework. All right, so with that said, we get off screen. Let's get to it here. 3 problems to go over. Number 12. When people smoke, the cotinine or the nicotine they absorb is converted to cotinine, which can be measured. Sample of 40 smokers has a mean cotinine level of 172.5 nanograms per milliliter. And assuming that sigma is known to be 119.5 nanograms per milliliter, test the claim that the mean cotinine levels of all smokers is equal to 200 nanograms per milliliter. Use the 0.05 level. All right. So with that said, let me get to my homework answers and let's see what's going on here. So number 12, look what I wrote here on my sheet. I wrote the information that was pertinent. It was 40 smokers, sample mean was 172.5, sigma 119.5. So hypotheses, mu equals 200 versus mu does not equal 200. Don't forget to write verbals. The mean cotinine levels of the smokers is 200 nanograms per milliliter versus it is not. Sigma level is 0.05, test statistic is Z, assumptions are as seen. Decision rule. Okay, so here we go. Since the alpha level is 0.05, what is the two-tailed decision rule for alpha 0.05? It's greater than 1.96 or less than negative 1.96. You do not need to draw a picture for that like we did in the notes. You can if you want to. Sometimes it's visually good. Then you have the computation. You actually take the 172.5 minus the 200, divide by 119.5 over root 40, and you get negative 1.46. This is why drawing a picture might be a good idea, because then you could visually see where things are going. So we're only rejecting if we get less than negative 1.96, all right, or greater than positive 1.96. We got negative 1.46, which is right here. And there's 0 just for reference. Okay, so is that in the reject HO region? Is it in the reject HO region? Or is it in the fail to reject HO region? It is in the fail to reject HO region. Okay, so that's our decision. Since Z is greater than negative 1.96, we must fail to reject HO. All right, and that's the actual statistical jargon right there. That is not guilty or unlucky. Fail to reject HO. Now you do the layman's terms. If you're failing to reject HO, that means you're actually going along with HO. That means you're accepting the fact that the mean cotinine levels are 200 nanograms per milliliter. That's it. Okay, now a very important note before we move along. From now on, basically, I'm only going to go over 4 things, and I put stars by them: the hypotheses, the decision rule, the computation, and the decision. If on the homework you don't want to put significance level, test statistic, or assumptions, that is your prerogative. You don't have to necessarily do that. I do that with this. I say that with this caveat. On the test, I will expect to see all of this. All right. So when we go over homework, we're just going to go over the big ones there: the hypotheses, the decision rule, the computation, and the decision. All right. So there's number 12. And again, this goes faster as we get more and more experienced with this. Let me get back to the book. 13 says, randomly selected statistics students of the author participated in their experiment to test their ability to determine when 60 seconds have passed. I really wish I could have done this with you that day. Or maybe I did. 40 students yielded a sample mean of 58.3 seconds. Assuming that sigma is 9.5 seconds, and use the 0.05 level to test the claim that the population mean is equal to 60 seconds. All right, so let's go back to our homework. So once again, 40 people were selected for this study. Sample mean was 58.3. So the mean either equals 60 or not. Verbals, population mean is equal to 60 versus it's not equal to 60. Remember, you need to write your verbals -1, but for each verbal you don't write. Alpha's 0.05, z-score is the test statistic, assumptions are the same. Decision rule, because alpha's 0.05, the decision rule is the same. But my z computation is -1.13. Not reinventing the wheel and drawing it all over again. -1.13 is -1.13 is like right there. Also in the fail to reject HO region. In the fail to reject HO region. So guess what? For number 13, since z is greater than -1.96, we must fail to reject HO. Not guilty, Your Honor. And we're accepting that the population mean is equal to 60 seconds. All right, so there is number 13. Last question of the homework, number 19. Let's get to it. Let me go back to share here. Let's share the book with you. Number 19. What does number 19 say? Sorry, scrolling down. Okay, so this is your first time that you actually need to go to the appendix in the back of the book. I don't know if this book has an appendix in the back, but I'll check it at the end. So it says use the weights from post 1964 quarters and data set 14 of Appendix B. Assuming that these quarters, if you have your book at home, perfect. Use your book at home and go to Appendix B in the very back and find data set 14. And you're using the post 1964 column in that. There's a ton of stuff. And yes, how do you do this? You actually, yeah, let me put myself on camera. You actually have to get your calculator, put all the data into L1 in your calculator. Yes, that's what you have to do. Put the data into L1 in your calculator, get 1 var stats, and then get the information from 1 var stats. Get X bar and take the sigma from X bar, right? Right, Griffin?
Yeah.
Yeah. So I am just, and it says, test the claim that the quarters are from a population mean equal to 5.67 grams. And then does it give a significance level? Yes, it says alpha 0.01 this time. So let's get to our homework. For number 19, there were 40 quarters in data set 14 of Appendix B. This is the data that I got right here from L1, 1 var stats in my calculator. I put all the quarters in, and I got 5.6393 and a sigma of 0.068. And then I got mu equals 5.67 versus it's not, alpha 0.01, z statistic, boom. What's the alpha 0.01 z statistic? It's plus 2.575 or less than negative 2.575. I'll draw this picture really fast. Boom, 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 boom. Here's 2.575 and negative 2.575. Okay, and when I do my computation, I get negative 2.86. Negative 2.86 falls over here. That's where it falls. It falls in the reject HO region. So we must reject HO. Guilty, Your Honor. We must reject HO. And if you reject HO, you're actually accepting H1. What does H1 say? That quarters don't have a mean of 5.67 grams. And when that happens, got to do a confidence interval. Best point estimate of the mean is actually the sample mean, 5.6393, with the following 99% confidence interval. So I took 5.6393, and I was a little lazy here. I just did plus or minus 2.575 times the sigma over root n, 0.068 over root 40. And I got from 5.612 to 5.667. And I was a little lazy with my verbal. So we are 99% confident that the true mean weight is between 5.612 grams and 5.667 grams. And I don't have to say what the best point estimate of, because I already did that right here. Okay, everybody. I'm not going to do videos for every homework, but I did it for this first one and maybe the next one. Bye, everybody.